Okay, we're continuing 12.3. We're going to use the limits process to find the slope of the graph at a certain point, or the slope of the graph is also the slope of the tangent line. And we can use those in various ways. So example 1 says find the slope of f of x equals x squared plus 3x at negative 5, 10. We found the slope using the limits process last class, so we'll do that the same way. The only difference is now they want it at the specific point of negative 5, 10. Okay, to find the limits, we were using the slope is the limit as h approaches 0 of f of x plus h. So let's do x plus h squared plus 3 times x plus h. And then I subtract f of x. And then the whole thing was over h. And then I'm going to go ahead and simplify that. And then we're going to go ahead and look for things that cancel because they normally do. X squared minus x squared, 3x minus 3x. Okay, and then it looks like everything else is going to stay, so let me write what I have. Okay, I'm going to factor out the h and then cancel it because I know that this will be indeterminate as is. Okay, then if I do direct substitution of h equals 0, I get the limit as h approaches 0 is actually 2x plus 3, which is an equation, which is fine because the slope varies at different points along the graph. However, now they want me to calculate the slope at the point negative 5, 10. So at negative 5, 10, the slope is going to be, using this formula, I'm going to plug in x as negative 5 because that's where I'm trying to evaluate it. So 2 times negative 5 plus 3, which is negative 10 plus 3, which is negative 7. So at negative 5, 10 on that parabola, the tangent line or the graph itself would have a slope of negative 7 at that point. Okay, let's go ahead and try one more like that, except we're going to write the equation of the tangent line and we're going to look at the graph too. Okay, so for example 2, we want to find an equation of the tangent line to the graph g of x equals square root of x plus 3 at 1, 2. After that, we're going to graph the function of the line. I'm going to go ahead and graph the function now so we can visualize what we're doing. I'm just going to do a sketch. G of x equals the square root of x plus 3. So this is the square root function. It's moved left 3 units. 1, 2, 3. So it's going to start here. It's going to tail this way. They gave me a point on the graph. They gave me 1, 2, so I'm going to use that point to kind of make my graph a little bit more exact while keeping it a sketch. So I know 1, 2 is also on the graph. Okay, this is enough points to get a good sketch. So I'm going to go ahead and sketch the function. It's going to go like this. Okay, so that's g of x. They want me to find the equation of the tangent line at 1, 2. Remember, the tangent line at that point is the one that just goes like this. So I'm trying to find the equation of a line that goes in that direction. The slope of the tangent line at this point should be the same as the slope of the graph at that point. So let's go ahead and find the slope of the graph at that point using the limits process. Okay, g of x plus h is going to be x plus h plus 3. Let me subtract g of x. And then the entire thing is over h. I do have to do something for it because right now it's indeterminate. Okay, I'm going to multiply by the conjugate. now if I distribute the numerator, I'll get x plus h plus 3, and then I'm subtracting x plus 3, which means I'm subtracting x plus 3 in parentheses, or I could distribute that negative. The whole thing's over h. Okay, let me simplify this. Oh no, I forgot my other factor at the bottom. Hold on. H, and then let me forget about that big conjugate. Okay, but now I'm going to simplify the numerator. Okay, so if I do x minus h, that cancels. H stays, and then if I do plus 3 minus 3, that also cancels. Okay, now I can cancel out the h, so this won't be indeterminate anymore. Okay, now I'm going to go ahead and substitute h is 0 here and do direct substitution, which is going to give me 1 over the square root of x plus 3 plus the square root of x plus 3, which I'm going to rewrite as 1 over 2 times the square root of x plus 3. So that's the equation of the slope of the graph. I specifically want the slope at 1, 2. So at 1, 2, which is really just saying x is 1, m equals 1 over 2 times 1 plus 3 is 4, which is 1/4. So the slope of the tangent line is 1/4. They actually want me to find the equation of the tangent line. I'm going to use point slope form because I think it's more convenient when they give me a point. So that's going to be y minus the y value equals the slope times x minus the x value. Okay, and this is the equation of the tangent line at that point. I'm going to sketch it below. If they ask you to change it to slope-intercept form, you could, but it's just not necessary. Okay, now let me look. Okay, at 2, 1, no, at 1, 2, the slope is 1/4. So I know it's going to pass through 1, 2, which I already have marked, and then the slope should be going up 1 over 4. 1, 2, 3, 4. It's just a sketch, but it should look kind of realistic given my graph. So it looks like the tangent line is going to go something like this, which is not perfect, but it does seem reasonable given the scenario.